Hello everyone and welcome back to my channel. So in today's video we are going to complete our block by block walkthrough of the SWIFT MT103 message by examining the last block, that is block 5. Block 5 is also called as the trailer block. So if you have watched the earlier parts of this series, you will know that the first 4 blocks have relatively visible roles. For example, block 1 identifies the sending interface and contains technical session information. Block 2 tells the Swift fin network what type of message is being sent, where it is going, and its priority. Block 3 contains your optional user header information, such as the UETR information. Block 4 contains the actual customer payment instruction. And today we will discuss about the block 5. Block 5 is a bit different. Technically, block 5 doesn't have any field for field mapping into the pacs.008 business message body. However, that does not mean its control disappear. It means that those controls are handled at a different layer in the ISO 20022 Swift messaging architecture. Before concentrating or before we talk on block 5, let us quickly go through the complete MT103 structure. So if you remember, MT103 is organized into 5 blocks, and every block has a different responsibility. Let's have a quick recap of all these 5 blocks. Block 1, or the basic header block. This is primarily a fin network header. It identifies the sender's logical terminal and contains technical information such as the session number and sequence number. These values help the fin messaging infrastructure identify and process the message. They are not customer payment details. Block 2, or the application header. Block 2 basically tells the fin network how the message should be delivered. It normally identifies the message type, the destination, who is the receiver, the message priority, and in some cases delivery monitoring information. Block 3 is the user header block. Block 3 basically contains your optional services and user header information. The most important example for payment messages, or from the payment message point of view, is the field 121. Field 121, if you remember, it basically captures the UETR information. Block 4, the text header block, is the heart of the customer payment. This is where we see the fields like 20, 32A, 50, 52, 59, and so on. Then we have the block 5, our today's focus. So block 5, basically also called as a trailer block. Block 5 contains the technical controls relating to the message integrity, possible duplication, delivery delay, text message identification, and certain system generated messages. It does not describe your payment information. It does not change the amount. It does not identify even a debtor or creditor. It does not tell the beneficiary bank where to credit the funds. Its purpose, the block 5's purpose, is to help the messaging infrastructure safely transport and control the message. Okay, now let's see the definition info about the block 5. So what is block 5 basically? Block 5 is known as what? Trailer block, because it appears at the end of the fin message. So if you see the format of the MT103, so you will basically see block 1 in the beginning, block 2 in the second block, then block 3, then block 4, and at the end you will have block 5. That's what we call it as that. The block 5 appears at the end of fin message. The word trailer simply means it follows the main message content, but do not think of it as a footer written by the payment customer. It is better understood as a network level control section. So control data answers a different set of questions. When we say it's network level control data, basically the question that comes under this control data are basically, has the message been corrupted during transmission? Could this message be duplicated? Is this a test message or a live message? Has the message experienced an unusual delivery today? So those are the types of questions those are addressed by your block 5. The bank's messaging infrastructure, SWIFT interface, or the payment gateway evaluates the technical controls. the validated business instruction is then passed to the payment processing application. This is one example of block 5 structure in MT103 message. Um, Here, number 5 basically identifies the trailer block, and inside this particular trailer block is there are multiple fields. Actually, you can see that it has this key pair in the key pair format, MSC, CHK. So each field has its own meaning, which we will discuss in the upcoming slides. Okay, now let us now examine the different types of trailer fields one by one that we observed in block 5, because this is where duplicate handling and technical monitoring become particularly interesting. Um, there are 8 types of trailer fields, as you can see on this particular table. Um, they do not all appear together, and some are associated only with specific services or exceptional situations. Let's start with the first one, MAC. MAC basically stands for Message Authentication Code. Conceptually, its purpose is to provide an authentication control over the message and help confirm that the message came through an authorized arrangement without unauthorized alteration. So MAC represents an authentication function, but not payment information. In modern ISO 20022 environment, authentication and digital integrity are normally controlled by the messaging infrastructure through certificates, signatures, secure transport, and related security services. Hence, there is no mapping for MAC in the MX message format. Second is CHK. CHK basically stands for checksum. The checksum helps the receiving infrastructure confirm that the message was not corrupted during transmission. For example, imagine that one character in an amount or account number or big code was accidentally altered while the message was traveling in between different banking systems. So an integrity check is designed to help detect the received message to detect that the received message is not identical to the transmitted message. The checksum is calculated by the system. It is not manually entered by a business user. It also does not identify the transaction. Hence, CSK is not a transaction reference. It is not a UETR. It is not a business message identifier as well. It is not even the payment amount. It is purely an integrity control. So Swift defines this particular trailer field CSK as appearing on general purpose application and FIN messages to allow the recipient to verify that the message was not corrupted during transmission. PDE, it basically stands for possible duplicate emission. The keyword here is emission, which refers to the message being submitted or emitted by the sender towards the FIN service. So PDE is added by this is added by sender, added by sender when the sender believes that the same message may already have been input to FIN. Okay, let us try to understand through a practical scenario. Suppose Bank A submits an MT103 for USD 10,000. 10,000 US dollar. Because of a connectivity issue, Bank A does not receive a clear acknowledgement confirming that the message was successfully accepted. Bank A now faces uncertainty. If it does nothing, the original payment might never be processed. But if it simply sends the payment again as a completely new instruction, the beneficiary might receive the money twice. So it's a loss to the bank or it's a loss to the sender. Bank A may therefore retransmit the message with a PDE indication. The It will say the message might have been submitted. Please perform duplicate checking before treating it as a new payment. So the receiving institution should therefore reconcile the message using relevant references and payment attributes before posting it again. So Swift defines PDE as a trailer added by the sender to warn the receiver that the same message may already have been sent as an input to the FIN service. PDM basically stands for your possible duplicate message. So although PDE and PDM sound similar, the party adding the indicator is different. Here PDE is added by the sender, but PDM is added by the FIN system. Okay, see the difference here. PDE is added by sender, but PDM is added by the fin system. So PDM warns the receiver that the same message may have already been output by the fin service. Just imagine that the fin service attempted to deliver a message to bank B. Because of a technical interruption or some technical issue, it is uncertain whether bank B successfully received and recorded the first delivery. So when fin delivers or redelivers the message, it may include a PDM indication. So the receiving bank must then treat it carefully and determine whether the payment has already entered its processing system. Next is DLM. DLM stands for delayed message. So this field indicates that a message was not delivered within the delivery system, within the delivery time defined for the applicable fin priority. This field indicates that a message was not delivered within the delivery time defined for the applicable fin priority. So in traditional fin definitions, the delivery monitoring period is shorter for urgent priority traffic and longer for normal priority traffic. For example, your 15 minutes for urgent messages and for example 100 minutes for normal messages. So the important point is that DLM describes the delivery behavior of the message, not the financial status of the underlying payment. A DLM indicator does not necessarily mean that the beneficiary has not been credited. It means that the fin message experienced a defined delivery delay. So this distinction is very important because message delivery and payment settlement are not the same thing, are not the same event. A message may be delivered, but later wait for compliance screening, liquidity, cut-off processing, or beneficiary account validation. Similarly, the delivery of a message does not by itself prove that the settlement has been completed. Okay. Next is the TNG. It stands that identifies the test and training message. So bank must keep a test transactions clearly separated from its live production transactions. Imagine that a bank is testing a new payment system or new payment engine and sends a sample MT103 using fictional customers and amounts. So without environmental control, there would be a serious risk that the message might be mistaken for a genuine payment, right? So the TNG trailer block, the TNG trailer field coming in the block 5 will tell the receiving environment that the traffic belongs to the fin test and training service. It is not it is not any customer payment. So this is another reason why TNG does not map into pacs.008 payment body. So SWIFT defines the TNG trailer as a trailer added to all fin test and testing training messages to identify them as a training traffic. MRF. It basically stands for message reference trailer. So this is not a general customer payment reference. It is associated with the fin copy, fin copy processing. So fin copy is a service in which a copy of fin message is sent to another destination, often for authorization, settlement, regulatory, or message infrastructure processing. So this fin copy is totally a different topic, different concept. Maybe someday I will try to bring a new video on the on solely on the fin copy itself. Then coming to SYS. So SYS stands for System Message Trailer. So SYS is associated with system generated messages. Not every message traveling through the fin is created by a bank employee or a customer payment application. The network also generates technical messages, acknowledgements, notifications, and other system traffic. These messages are not related to any customer credit transfer. So SYS trailer helps carry system level reference information for such processing. So as we have gone through this all 8 fields, these are important purposes, but their purposes are technical. None of these trailer fields describe the commercial instruction to transfer money from a debtor to a creditor. Okay. Okay. Now this led us to the central mapping question: why can we not simply create equivalent fields belonging to block 5 inside pacs.008? First reason, it belongs to different layer. So the first reason is that pacs.008 and block 5 operate at different layers. The pacs.008 message is a financial institution to financial institution customer credit transfer. Its job is to communicate a customer payment instruction between financial institutions. The pacs.008 message body contains your business information such as message identification, creation date time, settlement information, payment identification, amount, money, your debtor agent, creditor agent, intermediary agents, charges, purposes, remittance information, so on. But block 5 is not part of that business instruction. It belongs to the as we have already discussed, it belongs to control and transport layer. It belongs to control and transport layer um, to deliver the fin message. Reason 2, the pacs.008 business body does not contain, dedicated element called MAC, CHK, PDE, PDM. So adding those proprietary XML elements inside the standard MX message would break the schema compliance unless they were carried through an expressly permitted extension mechanism under an agreed market practice. So PEX 008 schema is not designed to reproduce the fin message character by character. ISO 20022 migration is about representing the required business meaning in a richer data model, while technical delivery controls are handled by the appropriate message layer. Third reason, the function survives even when the format changes. So this is the most important lesson from the slide from this video. So when moving from MT to ISO 20022 MX, we should not ask only where does this field go. We should also ask what purpose does this field serve, and which components performs that purpose in the new architecture. For example, the integrity function still exists. Authentication still exists. Duplicate prevention still exists. Your delivery monitoring still exists, and so on. But these controls, may now be delivered through like SWIFT transport service, network level security, certificates and signatures, the business application header, the SWIFT tracker, application level idempotency, payment engine duplicate controls, and so on. And this is called functional migration rather than literally field migration. Okay, now let us apply that principle to each trailer field and see where its responsibility is handled. Let's start with the MSC and CHK. So MSC and CHK do not move into pacs.008 payment body. Their overall objectives are authentication and integrity. So in an ISO 20022 over SWIFT environment, these objectives are addressed through secure network transport, certificates, signature mechanisms, and infrastructure level message validation. PDE and PDM. So they also do not have direct equivalent mapping inside the pacs.008 body. However, duplicate handling continues to be extremely important. A modern duplicate control design may use several layers. The network may detect repeated message submissions. The business application header may carry a possible duplicate indicator when permitted by the implementation. The receiving payment engine may implement idempotency and duplicate matching rules. We can talk about the role of EVTR also in this instance. So EVTR is valuable for your tracking and reconciliation. SWIFT compares the EVTR to a courier tracking number because it allows the payment to be followed across the payment chain. However, let me tell you, EVTR is not the same as PDE and PDM. PDE and PDM are warnings that the message may be a duplicate. However, EVTR, on the other hand, EVTR is an indicator assigned to the end-to-end payment transaction for checking purpose. A repeated EVTR may support duplicate detection, and SWIFT has implemented controls against EVTR recycling. So the presence of a EVTR is itself not a possible duplicate flag. Okay. DLM. So DLM does not become an element in the pacs.008 message body. Delivery monitoring is handled outside the business transaction. The SWIFT transport service can monitor whether a message has been delivered. TNG does not need a business element in pacs.008 because test versus production separation is controlled by the service environment. MRF is a fin copy specific, therefore does not have a standard mapping in an ordinary pacs.008 flow. So when an ISO 20022 implementation needs to reference another message, it should use the appropriate ISO 20022 reference element or the applicable market infrastructure mechanism. But it should not copy an MRF value into a random pacs.008 field simply because both are called references. SYS is associated with system generated network traffic rather than customer payment data. System acknowledgements, network notifications, and service messages are handled outside the pacs.008 customer payment body. For the pacs.008, it should remain focused on the customer credit transfer instruction. Okay, we can now summarize the complete MT1032 pacs.008 journey and see how the five blocks are treated differently. So this slide has been prepared to bring the entire video we have discussed explicitly together. So the five blocks should not all be mapped using the same method. Let's begin with block 1, basic header. Block 1 basically contains the fin sender interface session and sequence information. The fin session number and sequence number do not have direct destination to the pacs.008 business body or in the ISO 20022 business application header. However, the identity of the sending and receiving organization may be represented in the business application header element through from and to. Block 2 contains information such as your message type, destination, and priority. Equivalent message level concepts may be represented through your from element, to element, business message identifier, business service message definition identifier, priority. So the exact population will depend on the ISO 20022 version, SWIFT CVPR plus users guideline, and the selected business service. Block 3 or the user header has selective mappings. We can say field 121, the UETR, has a direct mapping in the ISO 20022 pacs.008 message body. Other fields may influence service identification, priority, or processing rules. Some fields may only remain in the audit or translation records. Therefore, block 3 is a combination of direct, derived, or non-map data. Block 4, the text block, is the most contains most of the business payment information. It is transformed into structured ISO 20022 sections, such as your group header elements, credit transfer transaction information elements. So all the most of the details covered under this particular block 4 comes inside the group header and credit transfer transaction information element. Then block 5, as we have already seen, it has no direct footprint, no direct mapping inside the pacs.008 business body. Its functions are absorbed or supported by your SWIFT transport controls, network security, message validation, duplicate detection, some checker or transaction manager services, and so on. So not every empty field must become an ISO 20022 business element. Some data migrates into the message body, some moves into the header, some might have to be derived, and some remains the responsibility of the messaging infrastructure. Okay, and with that, we have completed our walkthrough of MT103 Block 5 and its treatment in ISO 20022 pacs.008 MX format. If you found this explanation helpful, please subscribe to my channel Analyst After Hours. You can also watch the previous videos in this series covering all the other blocks, block 1, 2, 3, and 4. Together, these videos will help you understand not only the message formats but also the reasoning a business analyst should apply during an MT to ISO 20022 migration. Thank you for watching. I will see you in the next video. Bye.